Okay, I think we're good here, so we're going to get started. My name is Chris Banton. I'm the marketing manager here at EMA Design Automation. Just have a couple quick housekeeping items I want to cover with y'all before we get going. Basically, everyone's going to be on mute for the duration of the seminar because we have quite a few people online. You can ask questions through the question dialog in the tool panel that you have through GoToWebinar. We have people that will be answering them through the duration of the webinar, so please feel free to ask questions as we go along. And we'll try to have some time at the end to get through all of everyone's questions. We have a couple poll questions that we'd like people to answer for us as we move through the presentation. It just helps us, so please take the time and answer those for us as we go through this. So with that said, want to get started. This presentation is on PSpice. It's for PSpice tips and tricks. It's actually a cap-off to our seminar series we've done here in North America. So to kind of give you guys some background, EMA Design Automation was founded in 1989. We're a Cadence channel partner and reseller of the Cadence products throughout North America. So I'm sure a number of you are familiar with EMA. And we also sell Autodesk tools for doing mechanical design as well. Yeah, EMA provides a number of different tools and services. One, obviously, is analog and mixed signal design with PSpice and a number of add-on options for PSpice. We also provide tools for doing FPGA design or digital simulation with ALDEC and Timing Designer and Cadence FPGA System Planner. We have a full line of integrated, scalable PCB design solutions through the OrCAD platform. And we also provide engineering data management solutions to help you tie all that design data together and make sure that you have good data integrity through tools like our component information portal, our vaulting tool for file check-in and check-out, and then also our product lifecycle management tool, Omnify. So with that said, just a quick background of what EMA can provide beyond what we're going to cover today. I'd like to turn this over to Matthew Harms. He's our going to be presenting the PSpice content. He's an EMA application engineer. Matthew's been with the company for 9 years, specializing in simulation and supporting Capture, PSpice, advanced analysis, and even some of our signal integrity products as well. So with that said, Matthew, take it away.
All right, thank you, Chris. Hi, everyone. My name is Matthew Harms. I'm going to be walking you through some PSpice stuff today. What I'm going to do is I'm just going to start off with poll questions. So I've opened up our first poll. We're going to have a couple throughout the webinar today, and I just want to see what you guys are using. So I put a poll up asking which SPICE simulator do you use primarily. So we're just seeing some answers flow in there and kind of gauge our audience from what they're using by that. So I see a bunch of answers are coming in already. I appreciate the feedback. While you're doing that, I'll just kind of give you the agenda for what we're going to be talking about today. So I'm going to be going over some tips and tricks for the first little while. So just some things that you may or may not have known that you can do in PSpice, that some of it is newish, some of it's been around a while, and just going to walk you through a couple things that might make using PSpice a little bit easier. Next, I'm going to walk through making models, so how you bring in a model from the web and actually bring it into PSpice. That's something that lots of people want to do, so I'm going to just take a few minutes and cover how you actually bring a model in from a website and start using it in PSpice. What are all the steps that you need to go through? After that, we're going to talk about debugging and non-convergence. So this webinar has a bit of a focus on power supplies, but not too much. So we're going to be talking about things that could speed up your simulation time if it's taking too long, how to make things go faster, and how to make things converge if you're having problems with convergence. And at the end, we're just going to cover a few of the advanced options. I'm just going to mention them to you. I might show you a thing or two if I have time, but I don't imagine that I will. But we'll see. So I'm planning to spend about an hour. I'm planning on stopping myself at around 11. And after that, we'll have time for questions if you guys have some. So as Chris said there's questions open during the webinar, so if something I'm showing doesn't make sense or you have a question about something, you can feel free to ask, and we have people that will answer those questions for you. Okay, so thank you for voting in our poll. That's very useful information for us, and we're going to get going with our presentation here. Okay. By the way, this presentation information itself will be available. I think we can email it to you afterwards, so if that's important that you get a capture of these slides, that's something we can send off to you. And also, we're going to be archiving this webinar. So if I am going a little bit fast, it's because nobody's slowing me down with questions by design, I guess. And you can archive this, or we're going to archive this webinar, and you can access it at any time later on. Okay, so some tips and tricks and stuff like that in PSpice is where we're starting here. So new stuff in 16.3. We've added the ability to edit colors and make more advanced cursors in 16.3. So colors you've actually always been able to change, but now it's a lot easier to change them. So now there's a user interface in PSpice whereby you can change the background color, you can change your trace color, you can change your trace ordering. So sometimes people don't necessarily like the black background in PSpice. They want a different colored background, maybe white or gray or something else. And they don't like the trace color order that comes with PSpice. So I think by default it's green, red, yellow, blue, something like that, and then it goes through some more colors. So if you don't like those colors or one of those colors, you want to take it out of the rotation, you can do that now very easily with user interface. And that's available within PSpice. You can just go to Tools and the Options. Also, we've introduced enhanced cursors down here at the bottom, you can see. So what we've done with cursors down here is we've given you the ability to see all your cursors in a spreadsheet format as opposed to that little pop-up window. So previous to 16.3 had a little pop-up window with the XY of your two different cursors. You could have two of them. Now what we do is for those two cursors, you still have the same two cursors, but you get to see the XY location on every trace where that cursor intersects. So if you have 10 traces and you want to see all those 10 data points, you can easily get that information out. You can still see the delta X, the delta Y. All the information that you had previously is still available, plus additional information. And since it's in a spreadsheet, you can easily extract that information now out to Excel or some other spreadsheet tool that you might be interested in. Okay, so those are some new things in PSpice. See if I can get my next slide here. There we go. For those of you that are using CIS with Capture, some of you are. If you don't know what CIS is, it's not really that important. You can just ignore this slide. But for those that are using CIS, I just wanted to give you a little note on how you can actually use CIS and your database to manage your PSpice information as well, too. So if you're using CIS, you're probably using it to manage your symbols and your footprints and all your part data. But you can actually use it to manage your PSpice information as well. So the three properties that you need to have in your CIS database to manage PSpice is your implementation. So you do need your implementation property right there. And implementation is the name of the PSpice model. So that's the name of the model that you're actually pointing to. So if you're pointing to some diode, you would give the name of that diode. That would be your implementation value. Implementation type is always PSpice model. So for PSpice parts, implementation type is always equal to PSpice model, so that one's pretty easy. And PSpice template is a line of code that tells Capture how to netlist that part off so that PSpice can understand what's going on. So it's kind of a complex line of code. In Capture, it's a property, and it tells it how to netlist it off to PSpice. I wouldn't really recommend making this property by hand unless it's relatively simple and you know what you're doing. There are ways to auto-generate that when you make a part. We're going to be talking about that later on. So that I would just pull from an auto-generated part, put it into your database, and now all this information can be managed in your database. The benefit of managing all this information in your database is now if you have a design that's just done in Capture, but you want to make it PSpice intelligent so you can simulate it, if you have all this information in your database, you can just quickly sync it all in to your schematic, and then going forward, you now have your Capture designs turned into PSpice-ready Capture designs. And of course, you can have custom properties for correct use. So if you need things like value or voltage or power or different properties that PSpice is using, you can obviously have those in your CIS database as well. Okay, oops, too many things to click on here. Let's go back. There we go. Okay, so another thing that you can do in Capture is you can archive your design. So oftentimes what people are going to want to do is they want to send their PSpice design off to somebody else. So they have a PSpice design and they want to share that with somebody else. So maybe it's a colleague, maybe you just want to simply archive it to put it away for a later day. Maybe you want to send it off to tech support or someone at EMA just to take a look at things if you're having troubles. That can be difficult to do if you don't know the right way of doing it. So the right way to do it is to go to File, Archive, Project, and what that's going to do is it's going to wrap everything up for you, everything that PSpice needs to duplicate that in a convenient zip file. So what that's going to do is it takes your design file, it takes your project file, it's going to take any custom library files that you've made, it takes your simulation files, your profiles, it takes everything that you would need to send that file off. So let's say, for example, I made a file and I wanted to send it off to you, and I want you to just be able to open it and run it and get exactly the same results that I did. This is exactly how I would do that. So I could make up my design however I wanted to in PSpice. I could get the results I wanted to. And when I want to share that, just go to File, Archive, Project, and archive everything. It's going to put it into a single zip file here for me. And in that zip file, I could send that off to you. You would extract it, and it would keep track of everything, including custom libraries, and you would be able to use that then correctly. So that's a nice way of archiving your design, sending it off, and making sure that the people getting the files have everything that they need. So that's pretty convenient. Some people don't know that that exists, and they want to do stuff like that, so that's what I'm letting you know for. Also, just wanted to let you know an interesting thing in PSpice, and that's how to make a new design. So a new design based on an old one. How you do that in lots of other software tools is you would open the design that you want to use as a reference project, and then what you would do is you would hit Save As, and then at that point you would now have your reference project saved as the new name that you want, and then you could go forward changing that while it leaves your old reference design behind. Which is what you typically want to do. So make a copy of your design and start working off of that. You would use the Save As piece of the software. In ours, what you would do is in Capture, you would go New As. So you'd make a new project, and then you can choose to base it on an existing project. So what that allows you to do is when you make a new project and you make it mixed or analog to AD, so that's the PSpice, it's going to ask you, it's going to bring this pop-up screen here saying, do you want to create this based on an existing project? So kind of the new as an old design. And from that point, you can hit this drop-down right here, and off of that, you can choose an existing project that you've chosen before, or if you haven't chosen it before, you can hit this Browse button right there. And using that Browse button, you can find exactly the project that you like to base it on. So that's going to bring across everything for you. It brings across your simulation profile. It brings across your schematic. It brings across your library files. It brings across all kinds of stuff that you're going to need for your new project. So you can pretty much just use that as a start, your old project as a start, and go forward with this new one. So it's very useful. Okay. Some tips and tricks here. So those were a couple interesting things. If you ever got hung up with archiving or making a new project basing on an existing project, hopefully that helps out. Another one that people often like to do that they don't know they can do very well is importing and exporting information out of Capture and PSpice. So what you can do is you can oftentimes you often are doing PSpice for the purpose of documentation. So in Capture, you can easily grab a screenshot of your, or not a screenshot, you can easily capture everything in your design just by selecting it, hitting Control-C, and going off to Microsoft Word and hitting Paste. So you can easily capture an area of your screen, go off to something like Word or any other processing tool that you're using, and just pasting that in there, just using Windows types keys. So you might have known that. And in Probe, you can also make a nice copy of your waveform results out of Probe very easily as well. And you can do that by hitting Window, Copy to Clipboard. What I'm going to do is I'm going to hop off to the tool right after this next slide and show this to you. So it hopefully makes a little bit more sense. And thirdly, the other thing that you may want to archive, so first was the schematic, second was the waveforms, third thing you might want to capture is the actual data points. So if you have a bunch of data points that you want to capture, you can easily just select the name of the waveform and paste it into a tool like Excel or Notepad, anything you want, and it's going to grab all the data points that make up that waveform and probe. So that's another very useful feature for getting information out of Capture and PSpice. So let me show you what that looks like. I'm going to hop over to my Capture environment right here. And I'm just going to edit my simulation profile. I want to run a sweep here so I see all those waveforms. I'm going to be sweeping my capacitor value here. Don't worry too much about all these details, but I'm going to sweep this capacitor value over a big range, and I'm going to run this circuit. So basically what I'm doing is I'm doing one simulation run where I have about 25 different capacitors in here, and I'm just kind of cycling through them to get these results. So here you can see the actual results that I'm getting. I'm getting a ton of different results here. Now I want to start capturing some of this information. So the information that I want to capture is this screen right here. So I can just area select the items that I'm interested in documenting for the schematic, hit Control-C on my keyboard, go off to Microsoft Word is what I'm going to use in this case, and you can just paste that right in there. So Control-V, paste that in there. And you can resize this pretty nicely, so it resizes pretty easily there, and you can, of course, come in here then and type whatever you want. Okay. Next thing you might want to do is grab a copy of your waveforms. So you might want to take a copy of these and put it into your documentation as well. You can do that also quite easily. You don't have to do a print screen on this because then you get all that black background and you don't really want to print that out. So instead what you can do is go here to Window, Copy to Clipboard. And what that's going to let you do is it's going to let you copy this to your clipboard in a way that makes the plot background transparent. So instead of being black, it's going to be transparent. I'm going to hit OK and hit Control-V to paste that in there. And you can see that that does a pretty good job of cleaning that up for me. So it does a good job of getting rid of all those headers and changing my black background to transparent. And I can, of course, come in here and type up whatever I want to for that. Okay? So that's how I can get documentation for my schematic itself and for the waveforms that I'm getting off of that schematic. Next, let's get the data points out of here. So what I might want to do is I might want to take to an external tool all the data points that were used to make these waveforms here. So these waveforms are made up of a bunch of different data points. So this waveform has a ton of data points, this one has a ton. And I want to get all those data points for further analysis or some reason I want to get those out. So what you can do is just select the name of the waveform whose data points you want out. In this case, I want the current through the capacitor. It's going to turn red. What I want to do then is hit Control-C on my keyboard, which I've done, to copy that. And then I can go off to a tool like Notepad or Excel or whatever I want to paste this into. And there we go. I can paste it right in there. First column is just going to be my time. And my second column is going to be my first run, second run, third run, fourth run, etc. And I can scroll down here and see all those data points. Okay, so that's how you can get all your data points out of PSpice into an external tool like Excel, and you could then use that to do various things. I'm going to close that down and close this down. Okay, so that's how we can do some documentation. Let's hop back to the slides and see what's next. Making stimuli. Stimuli is another thing that that people often want to know how to make. So you can use the parts in the source STM library, and those are your stimulus libraries for making different types of waveforms. So you can make pulse type waveforms, which is going to be this this lower left one right here. So you can do pulses right there. You can do sine waves here. You can do piecewise linear. Piecewise linear are kind of good. These are the ones that I would recommend using this for, just because oftentimes if you have a waveform that's a bunch of data points, clicking them makes a little bit more sense often than adding them as text data points. Now, sometimes that's not true, but often it is that clicking them makes the most sense. And you also have your exponential here. So a bunch of different types of waveforms that you can make. from the source STM library. This is a library that's available in your installation, in your installed libraries in the PSpice directory. These were made off of the vstim part within the source STM library. I don't know if I'm going to go through that right now. We'll see what slide is next here. Yeah, I think I will actually. So what I'm going to do is I'm going to show you how you can use a text file as an input. So on this previous slide here, we saw on this PWL, piecewise linear. Piecewise linear is kind of like a connect the dots. You put in a bunch of data points and it just connects the dots and makes a waveform for you based off of that. What I want to do here is I want to make a piecewise linear waveform, but I want to have it based off of a big file that I have. So sometimes you're going to get files, or you're going to have created files, or you're going to get files of time and voltage points that you get from some other application. You want to use that to drive your PSpice circuit. So sometimes these types of waveforms that you have here aren't quite enough to make exactly the kind of waveform that you'd like to make. So what you can do is you can use a text file as a source. So here I have a text file with my time and my voltage points. So there's my time and there's my voltage. And I can see at 0 it's that, at this it's that. And these are essentially X, Y points on my graph that I'm going to use to drive my circuit. So I want to do that. I want to make a little circuit that does something exactly like that. So let me show you how to do that. You're going to use the vpwl_file part from the source library. That's what we're going to end up doing. Let me just show you how this works, if I can, kind of quickly. Okay, I'm gonna make a new project here, and I'm gonna base it on one that I've already made. So I'm going to show you that part too. Let's make a new project. I'm going to call it Demo Simple, and it's analog or mixed AD for PSpice. And I'm going to base it on an existing project. So I have a bunch of existing projects here, and I'm just going to base it on a simple RC circuit that I've made up. Hopefully this is correct. Let's find out. There we go. So this was the RC circuit that I based my new design off of, so it copies all that stuff in there for me with my probes in there, and everything comes across. I could run a simulation now on this. Let's just check what I'm simulating first. I'm going to 5 microseconds, and let's run this. And we'll see what's all happening with this circuit so far. Okay, so this is what I'm doing. I can see my input voltage here is 10 volts, and my output is being divided to 5 volts, and I can see the capacitor is being used to charge that up. So a very simple design here that I have. And what I want to do is I want to use a different input into this circuit instead of that DC source. So right now I have that 10-volt DC source, but I'd like to use some other waveform to drive my divider circuit here. So what I'm going to do, just for the case of simplicity, is I want to use this red waveform, this output waveform, and I want to take that waveform and drive it back into my circuit. I want to take exactly this waveform. So we've kind of seen already how we can pull that information out to a text file, and then we want to use that text file as a source. So to pull it out, let me just remind you, you're going to select the name of the trace that you want to pull out. So V out. I'm going to hit Control-C on my keyboard, and I'm going to open up Notepad here. And in Notepad, I'm just going to paste that in there. So there we go. There's all my time and voltage points. I'm going to get rid of that header line because I don't need that. And I'm going to save this to my, let's save it to my D drive right here. So let's call this demo.txt. Okay, so there's demo.txt right on my D drive. And I want to use that as my input now to my circuit. So instead of using this DC part, I want to use that file. So let's go here to place part, and in the source library, so I'm going to go up to the source library first. I need to add it because I don't have it here yet. So there's my source library, and I want to use the vpwl_file right there. So vpwl, that's V voltage, piecewise linear. Piecewise linear is the connect the dots part, and _file means that it's pointing to a file, which is what I want. You could also have one that repeats forever if you want, or repeats a number of times, but in my case, I'm just going to use the simple vpwl_file. So there we go. I'm going to put that in. I'm going to point it to my demo.txt file on my D drive, And what I should be seeing now is an input, so the green waveform on my resulting simulation now should be the same as my red waveform was previously. So if I did that correctly, let's find out if I did. Yeah, it looks good. Okay, so my input waveform now, this green one, is exactly the same as my red one used to be. And my red one, which is the output of this circuit, is a reflection of that new voltage source that I'm putting in. And you can see the current is corresponding to that as well, too. So that's how you can use a file as an input source for your simulation, and how you can get a file out of your own simulation, or you can get it from anywhere else and just save it off as a text file. Okay, so that's how you can use the file there. Another little tip that some people don't know, so I try and tell people as often as I see them about this one, is if you select a couple parts here and you go to Edit Properties, your property window is going to come up looking like this. So by default, it comes looking like this, where you have to scroll across to see everything. But that's not really a great use of your screen space. So a better way of seeing this information is to pivot this, so that instead of the properties being across the top, they're across the left-hand side. So to do that, you can double-click in this corner above the 1, or you can right-mouse click on it and hit Pivot. And that's going to pivot your data. So now the properties are vertically orientated, top to bottom there, and you can see all your information a little bit more readily. So that's a little tip. It's been around a really long time, but lots of people don't know about it, so I try and make sure people do. Hopefully that can be useful to you. Another one that's kind of useful, if you have a multi-page design, so if you have a project that spans multiple pages, it could be a flat design that was just simply a bunch of pages, or a hierarchical design with deep levels, you can go to Edit Properties for all those pages at one time if you'd like to. So to do that, you can go to your design file, and in my case I just have one page, so it's not going to be that useful, but what I can do is right mouse button on there and hit Edit Object Properties, and that's going to bring me to the same spreadsheet that I'm used to when I just select a single part or a number of parts in the schematic. So there we go. I can see now on the design level, I can see all the properties that exist on all my parts in my design. I could go up to the nets, to the flat nets, etc. I could go through and see all these different properties for my entire design. How this is useful is if you have a multi-page design and you have to change something on maybe all your resistors across your whole design. You want to change something, or maybe on all your nets you want to add a property to your VCC nets, some specific property. If you had to do that traditionally, you would go through to each page, find your VCC nets, and add the property to them, go to the next page, do the same thing. With this, you can just go to your schematic nets, and you could simply sort by name right here. In my case, my design is very simple, so I don't have those nets. But you could go through and sort by those nets and then add the properties you want to across multiple pages. So that's really the end goal here, is to change something consistently across all your pages in one location. And that's the purpose of that feature. This one's just a little tricky thing that we put into the tool in version 15.7. There's a good reason for it. I'm going to tell you the reason why it's there, which hopefully you'll agree with, and then we'll show you how to use it correctly. So in the Capture tool, what we added is the ability to prevent you from really messing up your design very thoroughly. So we prevented you by doing something like this. So if this was your design, and this is the default behavior of OrCAD Capture from version 15.7 to the current, what it'll do now is if you try and do something silly like that, so if I try to move that component, I'm essentially going to be shorting a bunch of stuff. So notice it's not letting me actually put that down there. I'm actually clicking my mouse here. It's not letting me put that down. In the lower left-hand corner, if you can read that, it said object move not completed as this resulted in connectivity changes. So what Capture is doing is it's saying that as you move components, it won't let you drop those components down if you're going to be making connectivity changes. So if you're going to be changing your net list, anything that connects, if you're going to be changing that by moving a component, it's going to prohibit you from doing that. You can just hit escape to get out of that command. So you'll notice that I can move it over here, I can move it over here, but I can't move it over there, and it won't let me do that. Now, sometimes people want to do stuff like that. So people want to be able to make changes like that, not exactly in this situation, but there's other situations where you may want to move a component and make changes. For example, like this. What if I, let me just do this. By the way, you can pull out a component out of here if you hold down the Alt key and drag away. That's the Alt key, and drag your part away. You can rip it up from the traces. What happens if I want to put that back in there? It's actually not going to let me for exactly the same reason. So I can't put that component back into there because I'm making netlist level changes. I'm changing what that cap is connected to by moving it in there. So there's kind of tricks to get around that, but the feature is located right here in the icon. So you can hit drag connected objects. That's the little icon. I'm going to toggle that button, and that puts me back to pre-15.7 behavior. So it allows me to do whatever I want to. And I can now drag and drop that component right into place there. So it's available from this icon right here, drag connected objects. The same exact feature is also available in your preferences, under miscellaneous, and under the wire drag section. So under wire drag, allow component move with connectivity changes is right there. So that's a new feature that had some people a little bit perplexed about how the tool was working. So if in case that was you, I thought I'd let you know why that is. Okay, so that's it for the tips and tricks section. What I'm going to do is move on to model creation now. And in model creation, I'm just going to talk to you about how you can bring in a model from the web into your tool. So there's other things that you can do with the model editor. I'll kind of mention some of them, but I'm just going to focus primarily on grabbing a model from the web and bringing it into PSpice to use it. So first off, what models come installed? We have lots of different models across lots of different vendors across lots of different regions. So we have over 30,000 parts. Lots of them are parameterized. We have BJTs, JFETs, all kinds of different parts. It kind of gives you a list here of a sampling of the types of parts that we have from all kinds of different vendors, and we have all kinds of different parts. So basically 30,000 parts, all ranges of parts available. Now, what happens if we don't have a model in there that you want, which is going to be the case. We can't have the models that everyone wants. 30,000 isn't enough to have everything that everyone wants. So what happens when we don't have the part that you want? If you can't find your part in the library, you need to find it elsewhere. So in this example, we're going to talk about finding it on the web. So if you can find that part on the web, you can then bring it into PSpice and start using it. You can hook it up with a symbol. You can place that symbol, and you can hook up the model. So you can do everything. You can grab it from the web and put it into PSpice in just 4 quick steps. So the steps, 4 might seem long, but they're actually really quick. So you can get through them quite quickly and see if there's some way you can bring that in. What I'm going to do just before I go into this is I'm just going to do another poll here. So I'm just going to take a little sidebar and check this out. I'm going to do, what version of OrCAD are you using? So just a little question just to keep you guys interactive a little bit here. So if you could let me know what version of OrCAD you're using, that would be great, so we can see where you guys are at. In my example here, I'm using 16.3, which is the latest version, and it's always interesting to see where people are at for versions. It was fun when we went around North America and we did the seminar that was pretty similar to this. We were asking people how long they've been using the tool, and pretty much in every city that we went to, there was someone that had been using it for more than 10 years. So there's a lot of long-time users out there. Maybe some of you have been using it for a pretty long time. Okay, I'll let you continue voting there, and I'm going to go on with the model creation here. So I'm just going to do slides for these 4 steps. So for importing, linking, placing, hooking, and then I'm going to actually go through and do a demonstration of that. So first off, if you can't find a model that you're looking for with our parts, you're going to typically go off to the web and try and find the model there. I hope my, I should probably close this poll so you can see my screen. All right, so I'm going to close that off, and then I think you guys can see my screen now. Great. So when you can't find the PSpice models in our list, you're going to go off to, typically you're going to go off to the manufacturer's website and see if they supply a PSpice model. Now, lots of the times they actually do supply models, and you can just grab them. So in this case, I'm showing a screenshot of Intersil's website, and some PSpice are some Spice models specifically at the bottom. So you can just go to the, usually it's at the bottom of the product web page, our SPICE models, and you can grab them from there. What you want to do with that model is you want to save it to your system as a .lib file. So whatever it comes as on the website, it might be TXT, it might be MOD, it might be CIR, it might be whatever it is, just save it off to .lib. That's what PSpice wants. By the way, there's a list of PSpice parts at this link location right here. And again, you're going to be getting these slides at some point, I believe, so you can just reference these slides if you want that link again later. Okay, so the second step, after you have that .lib file from the manufacturer, what you want to do is you want to make a symbol for it. And symbols are actually remarkably easy to make. You can make them very quickly just opening up the PSpice model editor, open up the library file that you just downloaded from the internet, and hit Make for Me a Symbol. And it's that simple. So it'll make you a symbol that corresponds to that library part, and now you have both your PSpice intelligence and you have your capture symbol. So you have both of those things together. Now, in some cases, and specifically in our case, when I'm going to run this demonstration for you, it's not going to make for me a very beautiful symbol. It's going to make for me kind of a square block. And what I want to do is I want to modify that so it looks more like an op-amp. And we're going to see how to do that too. So with the basic tool, what it's going to make in some parts cases, so in the case of sub-circuit parts, you can see that this part right here is a sub-circuit. In the case of sub-circuit parts, it's just going to make for you a square box because it doesn't know what that's supposed to be. But what you can do is you can map it to a symbol that you've already made that looks like what you want it to look like. And I'm going to show you how to do that. So using the basic extraction tool, the PSpice Model Editor Export, it's just going to make for you a box in the case of sub-circuit parts. If you want those to turn out correctly, use the Model Import Wizard instead. And I'm going to show you how to do all this stuff. Okay, so that's how you can make a symbol. It can make it for you automatically, or you can have some manual interaction and tell it which kind of symbol you'd like. All right, third step is to just place that symbol on your schematic. So very, very easy. You've made that symbol now in step 2. Simply place it now on your schematic by adding the library and placing it into your design. So one thing to note is that in 16.2, I think, we changed this place part interface. It might have been 16.3. And Add New Library is no longer a button that says Add New Library. It's this little thing right here. So it's this little dotted rectangle that has a little star in the upper left-hand corner. That's Add New Library. So you need to add the library that you made in step 2. And the last step is that you just need to configure your PSpice library. So the project, the Capture project is the thing that manages where all your libraries are, where all the intelligence for all the different parts reside. That's managed in the project. So the project needs to then be told where that library file is from step 1. So you need to go into the configuration files and add that library that you made from step 1. Okay, so let's do that. Let's go through and add a new part. So I'm going to go to this design that I was running before, this one with the cap and my oscillator. And I don't want to use this model anymore. So I want to use a different one. I'm going to delete that one out of there. I want to use one from Maxim. So there was a part that I wanted to use from Maxim. It was the 4211, I think. Yeah, so let's grab this 4211 part from Maxim, and you can see a bunch of stuff about it. I can verify that this is the part that I want, and ultimately I'm going to come down here to Software Models. Did I get this wrong? What part do I want to use here? This one doesn't have a model. 4211 was something else. I want the 30A46 maybe? Maybe that was it. Nick, you want to remind me which part I want to use? I can't quite remember. Just
hey,
checking
Matthew.
my notes. Hey, Nick.
I believe it's a MAX 4412.
Oh, okay. 4412. I was doing the 4411, I think. Thank you.
Oh, okay. Yeah.
Okay, so there's the 4412. And down here, there we go. So there's my models for this one. And what that opens up is a little model category here for me. And I can just click this macro model, and that's going to be exactly the model that I want. So here's that .lib stuff, or here's the SPICE model for this part. So it's kind of a bunch of ASCII code to tell me about this part, and what I want to do is I want to save that part. So I'm going to save this page, I'm going to save it to my desktop, and I'm going to save it as a .lib. So that's what I wanted to do. I want to save that as .lib, max4412.lib. And once I have that saved off, now what I want to do is I want to go to my desktop, or I want to open up the PSpice model editor is what I want to do now. So let's open up the PSpice model editor, and this just comes with your PSpice tool. So in the PSpice model editor, what I can do is I can go to export to capture part library. And this makes for me that basic square shape, which I'm going to see. So let's go off to my desktop, grab that library file, and I want to make a symbol file for that. So capture symbol file is a .olb. So let's make that one. And that already made for me a symbol library. So what I can do now in Capture to place that, I can go, I need to add that library. Let's go to my desktop, and there's the 4412 part that I was looking for. But you'll notice here that that doesn't really look like an op-amp. It's going to be hard to place that one correctly and get it all wired up. So that didn't work out so well. A different way of doing this is to use the model import wizard instead in the PSpice model editor. So let's do that. Let's browse for that same file again, the 4412, and this time I'm going to make an _2 library file. And what it's going to do is it's going to say this model doesn't have a corresponding symbol, so I'd like to associate a symbol with that. I've already done this before, so it takes it from the op-amp library. I can really take any op-amp that I want to, so I'll just take that one. It doesn't really matter. And the tricky part now is mapping your model terminal, so the pins from your model to the symbols on your schematic part. And that can be tricky, except for it's made easy because you can hit this view model text. So as view model text, the manufacturer always gives you mapping for this. So pin 1 is equal to in positive. So you can see that right there. So pin 1 is in positive, pin 2 is VEE, and pin 3 is in negative, pin 4 is out, pin 5 is VCC. There we go. So now all the mapping is correctly mapped from my PSpice model to my OrCAD symbol. I can hit OK. I can finish that off. I can hit OK here. And now I can browse for that new _2 library and place that part right into my schematic. Let's just vertically flip this thing so I get my powers lined up. Is that what I want to do? I think that's what I wanted. Yep. Okay. So there's my 4412 in there right now. One thing to note is that if I try and simulate this right now, it's not quite going to work because I haven't told it where the model for this 4412 is yet. So let's do that. Let's tell it where the model is, and you do that in the configuration files in the library section. And I'm going to browse for that .lib file that I made in step 1. I'm going to add it to the design, which means that for every time this design is open, that part's going to be available. If I make a new design, this part will not be available. If I want this to always be available, I can hit Add as Global instead. Let's hit OK. And at that point, I should be done correctly. We're going to find out pretty quickly if I did that right or not. And it looks good. So the results here look really similar to what I was seeing before, so it looks like things are correctly hooked up and working with my new model here in place of my old. So now I get to see some new results that accurately reflect that maxim part. Okay, so that, let's just hop back to slides here. That was the steps to import a model. So import a PSpice model from the web, link the model to a symbol using automatic or the custom symbols, in my case the op-amp, place that OrCAD symbol on your schematic, and then hook it all up. The fifth step that we would normally recommend is to then actually go and test that model. So throw it into some circuit where you know what it should be doing, or you can see some curves that are characteristic that you can kind of verify against the data sheet, and make sure that that part is actually working correctly. So that's a fifth step that we would certainly recommend for any part that you use in your designs. Okay, so that's the model section. I'm going to move on to convergence helping section, and this one I am running short on time, so I'm going to have to go as quickly as possible. So I might be showing a little bit less of this in the tool itself, but hopefully this is going to make enough sense. Okay, some tips and tricks for improving convergence or getting away from non-convergence. and debugging your circuit. So some things that we can do include scheduling tolerances, checkpoint restarts, auto-convergence, and making assertions. So in this example right here, this might be a circuit simulation where if you run this one along here on the X, you would be cruising along here, and all of a sudden right here, you'd get a non-convergence problem. So you'd get a spike in your simulation results, and it might say it can't converge past that. At which point you would try and maybe loosen your tolerances and try and figure things out. But if this is a spike that you're aware of, what you can do is you can schedule things. So you can say, I'd like to change my step size first off. So if you just change your step size to something really small, then it can take a lot of time actually getting out there. So the simulation time, if you take really small steps, can take a long time getting out there, and then it will simulate past that, but it just took a really long time doing that. So instead of running it really long the whole way, you can instead come through here and run this really fast to here because there's not much going on. Run this part slow, and then run this really fast again. And you can do that using the schedule command, and you can pop that into a lot of different tolerances that you have available to you, like maximum step size, rel tol, abstol, vintol, gmin, itl4, tmax. So the format of it is curly brackets, the word schedule, round brackets, and the time 1. So in this case, time 1 would be 0, and my value 1 might be 0, which means in the case of maximum step size that I don't really care what it is. At time 2, you're going to specify as around 170 microseconds, and the value 2 might be something really small, so 1 nanosecond step size or something really tiny. And then at time 3 might be at 1, or I guess it would have been more at around 179 or something like that. And then at 182 or so, you could come out here and say you can go back to whatever you wanted to. So that's how the schedule works and how you can apply it to a situation like this to speed up your simulation time when it can go fast and slow it down when it can go slow and then speed it back up again. Okay, next thing we want to do is checkpoint restart. So in some circuits, what you see sometimes is charge up times that take a really long time to actually simulate. So they can take maybe a minute, 2 minutes, 5 minutes, 10 minutes, but anytime you're just sitting there waiting is time wasted. So if you can go faster, that's certainly better. So what people do in some cases is they run a simulation, get your charge up time, and in this case, this simulation only took me a couple microseconds. But you can run simulations like this that take a lot longer if they're taking more things into account. I'm just taking a simple example. What you can do then next is you can go through and try and do you can run some checkpoints on that. And checkpoints kind of look like this. You say, I want all my information at all these different points as I'm simulating along here. And then what you do with those checkpoints is you can say, instead of running all this stuff back here again, I want to start right here and I want to simulate forward. So I want to use that as a checkpoint so I don't have to waste all the time used in running this initial section and just simulate off of that using my checkpoint. And you can do as many of those as you want to. So you can run another one, and you can change your loads around in this case at different times and get different offshoots from your main waveform. So that's how checkpoint restart works. It kind of saves your bias points at all kinds of conditions, and then you can go back later on and toggle some values in your circuit and see what kind of changes that makes to your design. Here's a good one that I want to spend just a minute on. Autoconvergence. So what autoconvergence does is it really solves a lot of problems. So previous to version 16.2, I think this came out at, I might be wrong, but it came out a few versions ago, and what it allowed you to do is autoconverge. So let me just show you how that works really quickly here. So let's open up a project. I want to open up this one right here. Okay, so in this example, what I'm going to get historically with older PSpice simulators that have no autoconverge features, I'm going to turn it off for this one. So with no autoconvergence on, I'm going to run a simulation on this design, and it's going to give me some problems with that. So it comes up and says it just didn't work, and at this point you can try and change things around if you want to and see if you can make it work, but in this case I'm not going to be able to make it work. So that's kind of frustrating. At this point, I have to figure out what's wrong with my circuit, why it's not converging, and that didn't really work out. So now I really have to break things down and kind of dig into it quite a bit, maybe more than I'd want to. So what PSpice allows you to do now is you can just turn auto converge on. So auto converge, what it's going to do is it has loose tolerances for these different values that you have. So notice right here your rel-tol is 0.1% nominally. So that's what I'd like to use. I'd like it to use 0.1%. But if you need to use a different value, you can go up to 5% if you want to. And I have different relaxed limitations for all these different tolerance settings. So I'm going to hit OK here and OK. And now with auto converge on, I'm going to run this and I'll restart the simulation here. And it'll go through and just tear through that, no problem now. So you can see on the bottom here, it's just churning right through that. So 1, 2, 4, it got right through that, no problem. And I get to see some results. So that's just fantastic. I get to actually see some results for my simulation, and I get to see what's going on. I'm not just stuck with text data and trying to decipher what all those non-convergence files mean. I can just get past that and see what I want to see. Now, what does it do to make that happen? You can go to the output file here, and in the output file, right at the bottom, it's going to tell you the convergence settings it's finally succeeded with. So iteration limited changed, abstol, and vintol, it changed to these values. So you'll notice what it didn't do here is what it didn't do is just take everything you gave it for loose tolerance settings and use that. So it really surgically kind of pecked away at what you gave it and took what it needed but didn't take everything you gave it. So that way your tolerance still stays as tight as it possibly can. While looser than what you wanted, it's still as tight as it possibly can be to get some results. So that's a really nice feature in PSpice for new users and for old users, for people that have used it for a long time as well as new ones. So that's one of my favorite new features. I think it's pretty great. So hopefully you guys get a chance to check it out. Okay, I'm going to skip behavioral assertions because I'm running out of time. And I'm just going to mention some of the advanced options. Before I do that, I'm going to hop off and show you guys another poll. So here's the next poll. Do you use advanced analysis, PSpice advanced analysis? So just answer me if you could, if you use that. And once we're done that, we're going to talk about what it is and some other features that tack on top of PSpice. So far what I've covered is just in the basic PSpice tool. Everything that you've seen is available in the basic PSpice with Capture. And now I'm going to kind of hop in and show you a couple features that are additional to the flow. So things that you can tack on top of the regular PSpice. Okay, I think we've stabilized there. Perfect. Lots of you actually have not heard of advanced analysis, so I'm gonna hopefully enlighten you guys. Okay. So I'm going to close that off and hop back here. Thank you very much for your feedback. First, before I talk about advanced analysis, I'm going to mention, let's just hop back here one slide, SLPS. So SLPS is a tool that integrates your PSpice with MATLAB. So if you're using Simulink from MathWorks and you would like to put some circuit intelligence into that the Simulink flow, you can do that with SLPS. What SLPS does, SL stands for Simulink, PS for PSpice, SLPS. It allows Simulink to be the master of the simulation. So it runs its simulation, but as it's running along, it's going to talk off to PSpice. So you can put real PSpice circuitry right into your Simulink flow and do co-simulation with the two. So Simulink is kind of the master. It's going through, and at every time step, it's calling for PSpice to solve its portion of the circuit and pass that information back. So they kind of walk together and do co-simulation. That's really powerful if you have control systems or something designed with Simulink and you want to put some real circuit intelligence into there from PSpice as opposed to the more ideal stuff that Simulink would come with. It's a really good pairing. Simulink is a very strong control system tool, and doing stuff like that can be very useful. So that's a tool that we offer. Another one that we offer is if you're doing power supply design and you want some power IC models, we work with a company called AEI, and a big part of their business is just making models. So they're very, very good at it. They make excellent bench verified models that they sell. So we have lots of models available that come with the tool already. These ones are ones that we typically don't offer with the tool, and you often can't even get them online. So if you want to purchase these as a bundle, there's a couple hundred parts in there, and you can get them as a bundle. Really, if you use one of those parts, it's going to be worth purchasing the library. So they're Power IC models for managing your power supplies. Very good models, test bench verified, which is more than almost anyone can say about models that they're selling, including us and most vendors. So very, very good tool, or a very good library, I should say. Lastly, PSpice Advanced Analysis. There are 5 features in Advanced Analysis that you can use to supplement the functionality of your PSpice tool. So those features are smoke analysis, and that will determine component stress. So how far are you pushing the components in your design? When are they going to release the smoke that's inside of them? You want to know that, and that's a feature in Advanced Analysis. So you're going to tell it what the maximums of all my components are. So for my resistor, this is the maximum power it can dissipate, maximum voltage, maximum current, all kinds of maximums. You're going to do that for all of your parts. Lots of our parts already come with that information, and really putting it in is very easy. You can get that information from the data sheet, put it into our model, and you're going to be good to go. Then you simply run a simulation in PSpice like you normally do and say, run smoke on that simulation. Tell me how far I pushed my components. So is my resistor using up 2 watts when it's supposed to be a 1/4 watt? And it's going to tell you stuff like that. So very, very useful information. We find it especially popular with military and aerospace, but really anyone can benefit from that. Sensitivity analysis identifies critical circuit components. So what it's going to do is you're going to say, I have certain measurements that I'm interested in, and I want to know for those measurements, how sensitive am I to various components in my design changing? So if my resistor changes a little bit based on some tolerance, I might get a different one. How much does that affect my maximum or my bandwidth or my gain or something like that of my circuit? You can do that very quickly and easily with sensitivity, which also tells you worst case analysis for your tool. Now note that worst case analysis does exist in the regular PSpice tool. This sensitivity tool just is a lot easier to use and gives you a lot more information. So it is kind of an overlap a bit with some additional functionality. Smoke, by the way, was brand new functionality. We don't have that in regular PSpice. So that was smoke and sensitivity. Next is Optimizer. Optimizer is another tool that really doesn't exist in the PSpice tool in any way, and it's fantastic. What it allows you to do is say, my circuit's not exactly behaving how I want it to. Here's how I'd like it to behave. Please go and do that. So you can tell it my gain isn't working right, my rise time isn't right, my bandwidth isn't right, my maximum is wrong. All these different things. Tell it what you want it to be, and then say, go and do that. And it'll go through with the topology that you've given it and try and change values around of components to make it match or make it optimized. I might take a second here just at the end of this and show you how that works. Monte Carlo is a bit of a repeat in regular PSpice. Again, it's a little bit easier to use. It's going to tell you how many boards you might have to throw away based on your tolerances changing, based on your minimum and maximum spec for various measurements. The benefits of this Monte Carlo is that it allows you to do multiple measurements across multiple simulation profiles at one time. Lastly is the parametric plotter. This is another new feature that doesn't exist really in PSpice. In PSpice, you can sweep one variable, and you even saw me do that in my example right here. In parametric plotter, you can sweep as many variables as you want to. So as many resistors, as many different voltages, whatever you want to sweep, you can sweep as many of those things as you want to. And then you can view those results against each other. So you can plot those against each other to see how 2 variables interrelate with each other. And that can be some really valuable information too. So that's the 5th feature. Let me see where I'm at here for slides. I think I might be done. If I am, yeah, I'm done. Okay, so what I'm going to do just before I finish off is I'm going to show you Optimizer. We're going to finish up our web demonstration at that point, and after that, I'm going to open it up for Q&A. So I'm trying to respect your guys' time. I think we had booked you for an hour. If you're available to stay past this hour, that's fantastic. We'd love to have you stay. And I can answer questions with you guys, but at the same time, we will be over here in just a minute or two. Okay, so I'm just going to show you the optimizer. The other ones I'm going to leave to your imagination, I guess, so far. And let's go off and do that optimizer because it's pretty neat. Okay, so I'm going to open up a circuit right here. And this circuit, I have a two-stage filter right here. And what I want to do is I want to see what it's doing first off. So I'm just going to run a simulation on this to see what kind of results I'm getting out of here. And I can see that's what I'm getting. So that's what my gain looks like in red, and my phase looks like in green. So I can see those two different waveforms and see what they're doing. And at this point, I can say, well, that's not really exactly what I wanted. I wanted something that looks more like this. So this is what I want. I have these frequency points, phase, and gain. So I have a text file that tells me everything about this that I'd like it to be doing, which it's not doing right now. I'll just spoil the fun. So it's not exactly doing this, but I'd like it to do this. So how would I do that? If you were tasked with this, you would probably have a pretty difficult time doing it. There would be a lot of guessing and checking, maybe a few sweeps going on here and there, but that would be a pretty tough job. With the optimizer, it's pretty easy. So with the optimizer, all you're going to do is go up here to Advanced Analysis to the optimizer. And what I've done is I've taken those outputs and I'm mapping them to that text file. So I've done that ahead of time. So the text file is right here. The gain column is matched to my gain measurement. And the same reference file, the phase column, is matched to my phase measurement. And I'm telling it you can change anything in the design. So all those different components you can go through and change. I'm just matching it to a 3 and a 5% tolerance. So it's not extremely tight, but it's hopefully tight enough to see the capabilities of the tool. So what we're going to do now is go through this, and on our waveforms here, we're going to be seeing actually what it's doing. So the red waveform is what we have in our text file on the top and the bottom. The top is the phase, the bottom is the gain, and the green is what the circuit is doing right now. So as it's optimizing, as it's changing values within my circuit, it's trying to move that green waveform on top of the red one so that we can get corresponding resistor and capacitor values in this circuit's case for this simulation to put the gain and the phase exactly how we want them based on that text file that we had. So it's going through and optimizing that for us, which is saving us a lot of time. And it's going to do a pretty decent job. It's going to get that pretty close. And what you can actually do is you can have this run quite a bit longer. So you can put this into a more thorough regimen and have it get very, very close. And that can run, I've seen this run for about an hour or so, and they get virtually right on top of each other. So you can get extreme accuracy. In my case, I didn't worry about it too much, just for the sake of demonstration. But you can see that I got very, very close. So my green waveform now is very close on top of my red waveform. I can see what it actually did to come up with that. So let's go back and see what it did to come up with that. And these are the values that it chose. So those are the resistor values right there. These are the capacitor values that it chose. These were my original values right here and right here. And there we go. So that got me to within 3 and 5% on my gain. I could then go and map this to purchasable components. So you obviously can't purchase an 861 ohm resistor, but you can map that to resistors that are available on a 1% table, 5 or 10. And you can make custom tables if you don't like ours too. But you can map those to those tables. Hit run again, and it's going to map those to purchasable components on those tables. Okay, so that's everything I wanted to show you. Thank you very much for your patience with me and letting me show you all kinds of stuff. I'm just going to kind of end off here with some supplemental resources. So if you want information on PSpice models that we have, here is that link that I had in the slideshow before. If you want information on PSpice, you can go to our product page here. These are all just direct links. You can traverse to these links throughout our web page, which is just ema-eda.com. So if you want to get to any of these product links, you can do that on our web page. I believe you're also going to be getting the slides, so you can click on those once you get these slides as well too. So PSpice, Advanced Analysis, SLPS, Power IC Model Library, some videos on how to use PSpice. We also have some on YouTube if you want to check them out there, and the demo software. So if you don't have PSpice, you'd like to try it out, you can download the demo software as well too. And I'm going to let Chris finish this off now if he's still around and available, please.
Thanks, Matthew. Appreciate it's a great job. So, yeah, just to kind of close it off here for everybody, want to thank you for attending. Below is our numbers for support or calling us, with any questions. I know a number of you have asked some questions that we've directed you to support for. As Matthew mentioned, we'll be archiving the webinar. That'll be available shortly, as well as the presentation materials. So we'll get that out to you guys as soon as possible.
Great.
Oh, Matthew, I'm sorry. I think there's one more slide there.
Oh, is there? I'm sorry. There you go.
So I just want to give everyone a reminder that we have a kind of a companion webinar that's going to be presented by Cadence for switch mode power supplies. This was the other half to our seminar series that we did here in North America. So I'd encourage you all to sign up for that webinar as well. It's a great hands-on experience to see how you use PSpice to design your switch mode power supplies. So with that said, we'll be online for a little bit here, so if people still have questions, we're happy to stay on and answer them. We do keep a record, so if we didn't get to your question, you can expect some follow-up from us as soon as possible. Yeah, thank you very much for attending. We appreciate it.
Yeah, thank you very much, everybody. So you're dismissed if you'd like to go. If you want to hang around and ask some questions or listen to questions being asked, if there are some, please feel free to hang around. Nikhil, if you're around too, if you have some questions that you think might be useful to talk to everyone about too, that would be fine. Do we have the ability to open up the lines for people to talk as well too? Do you know?
We cannot open up the lines to everybody, but if somebody has a specific question, if you could please raise your hand and I will unmute you at that time.
Okay, thank you, Kelly.
Okay. It looks like we have a couple of questions. We'll start with Andy D. Do you have a question?
Yes. I was looking into the SMPS because that's what we do here. And I was trying to verify a design of mine, and the switcher I was using was an ST component. It's a Viper 16. The switcher made by ST Microelectronics.
Okay.
And do you think that AEI will be able to suffice that, or I mean, I can use an FPS in conjunction with a eMOSFET and do a round-robin control?
Okay. So I don't know off the top of my head all the models that that AEI provides. I know that we have a link on our website to a product page that has all the models that they provide. Have you checked that link to see if your part's on there already?
No, I haven't yet.
Okay, that's fine. So what I would recommend is check that link. If they don't have that part available, I can certainly put you in touch with them, and you could ask them if that's in their pipeline to make that part. Also, if you're interested in getting them to make you that part, you can also get them to make parts. They'll make any custom parts you want to.
Okay.
All right. Thank you. Any other questions, Kelly?
And all I need to do is just send them the technical data sheet of Viper 16, right?
Yeah, that would certainly work.
Okay.
Anyone else, Kelly?
Looks like Jose Grassi. Do you have a question?
Hello, Jose?
Oh, yes? Jose? Okay, maybe he doesn't. Okay, anybody else? Just go ahead and raise your hand.
Since we're kind of sitting around here too, I just opened up another poll. What kind of design work you're doing? I noticed lots of people are hanging around too, so if you wouldn't mind answering that, that would be great too.
Okay. We do have a couple more, so how about Eric Williams, if you're unmuted?
Eric, hello, this is Matthew. Eric? The audio's not coming through very good on any of these.
Yeah, I think people are still furiously asking questions through the...
Okay, should we just tackle some questions that are being typed? Would that work better?
It might. So we can just kind of move to that, and we'll add Matthew's answers to Nikhil's and hopefully try to work through some of these.
Okay, so did you want to do that right now? Do you want to talk through some questions, or do you just want to answer those offline?
We could, well, we can try to work through some of these now. Like you said, if Nikhil has a couple that he thinks would apply to multiple people, we could answer some of those.
That's fine. Let's do 2 of those, and then we'll close it off, I think. So if Nick has 2, we could answer those.
Okay.
Thanks for your answers, by the way, on the types of designs you're making. I see I missed some categories that people are definitely designing in. There was a lot of others there. Last poll I'm going to put up while we're getting a question here. Hopefully you can take a second to answer those as well. Nick, did you have a question for me?
I'm looking at that, Matthew.
Okay. If you don't, that's fine too. And just one that you think lots of people would benefit from.
Okay. Okay.
Okay, so just the results of this poll are coming in, and there are some interesting results there. So lots of people are saying that building PSpice models is the biggest challenge that you face in your PSpice design. So maybe it's the biggest challenge because you all just learned how to do finding PSpice models, so that might not be the biggest problem because you just learned how to do that. But building PSpice models is actually not that hard either. I didn't cover it very much because I was short on time here, but let's actually do that. I'm going to take a couple minutes here since there's some people hanging around. I think I'll cover that, and then I think we'll end it off. So let's, I'm going to close down this poll here and show you my screen, just how you would create a model if you didn't find one on the web. So this is kind of the third portion to what I was talking about here before. Okay, so let's go back over here. You might remember this. Which one was I working on? This one? No, it was this one over here. So this one over here I was working on, and I found that Max 4412 on the website, so I was able to pull in that SPICE model and bring it into my PSpice simulation and simulate with it. So that wasn't too bad. But what happens if we don't have a model and there's no models online available, and now I'm kind of stuck? So what you're often going to do is just change your part. So if you really want to simulate it, you'll probably find one that's similar and just simulate that one. But what you can do is you can really make those parts, and you can make them quite easily as well too. So using the PSpice model editor, what you can do is you can make a new, I'm going to make a new library. You could add these parts obviously to an existing library if you wanted to, but I'm just going to make a new one for simplicity's sake, and you can make a new model. So if you want to make a new model, we have a couple different template parts that you can choose from here. So diodes, BJTs, cores, etc. I'm going to make a diode, again, for simplicity, and I'll call it demo diode, and I'm going to save that one off. So this is kind of back to, if you remember our slides from before about finding models, we're kind of at step 1 right now. So Cadence, or OrCAD didn't have that model. It didn't exist online, so now I'm tasked with making this thing. And normally, if you've been using SPICE for a while, this is what you're going to be up against. You're going to have to go in here and you're going to have to edit these properties. And that's going to be a massive challenge. So what we allow you to do in PSpice instead is something that makes this process a lot easier. And what that is you can enter points on your forward current curve. Same thing on your junction capacitance, reverse leakage, reverse breakdown, reverse recovery. These are obviously all going to change depending on what type of part you're using. In my case, it's a diode. In other parts cases, it's going to be something different. So what you're going to do is you're going to take a look at your data sheet now. You're going to say, okay, on my data sheet, my forward voltage at 0.6, or my forward current at 0.6 volts is 1 microamp. You're going to do the same thing, taking a look at your data sheet the whole time, and you're going to say 100 micro, and at 0.8, it's, what is it going to be, 10 milli. Oops. At 0.8, it's 10 milli, and at 1, it's 1. So you can enter a bunch of points off of your data sheet and essentially make this part. Now, what you can do next is you can say, I'd like to create a PSpice model that does what those points that I've put in there and on my other graphs do. So what it's going to do is it's going to change these parameter names, or parameter values down here, to affect this curve so that it gets through those points as closely as it can. It's going to do that all very rapidly. Once I hit Tools, Extract Parameters, it's going to be basically instantaneous, and it's going to be done. Okay, so I changed those values, the PSpice parameters, to match those curves through the data points that I've picked right here. Okay, and now I've pretty much completed step 1, so I can save this off. I'll save this off to my desktop as demo diode lib, and this is my .lib file that I have, and then I can do the same thing I did before. I can export this to Capture Part Library, so this was step 2, making that library file, so the Capture library file. I'll hit OK there again. And then step 3 was just putting it into my schematic. So step 3 was just placing that part. So I need to add the library, place the demo library right there. And notice in the case of a diode here that it actually comes up looking like a diode. And that's because diode is not a subcircuit, it's actually a model, so it comes through correctly. And that was our 3rd step, just place it in our schematic. The 4th step is to just configure it. So I just need to configure it because I made that new library file instead of placing it in an existing one. So I'm just going to configure that for the design, and at that point I'm done. That's everything I need to do. I can now wire this into my circuit however I want to and run my analysis. So that took me all of, I don't know, 5 minutes maybe, to make a model based on a data sheet that I have, match it to your PSpice curves that you have in the PSpice model editor, and run a simulation. So really, you just need the basic PSpice tool, your data sheet, and you should be able to make lots of different parts like that. Okay, so with that, hopefully that helps you feel a little bit better about building PSpice models. I know that that was a challenge that lots of you are facing. So hopefully that helps. If you do have questions that haven't been answered yet, we're going to be getting back to them shortly, as Chris said. And if you have any other additional questions afterwards, you can always just get in contact with EMA. And I think our information is on our website, or maybe even on this slide as well, too. Let's see, right here. Was it on here? Yeah, there we go. So you can get in contact with us this way as well, too. I'll leave this slide up for a minute. You guys can jot down the information if you need any of that. And other than that, I'm going to be signing off here. So I'm going to go on mute. You guys can copy this down. I'll be ending the webinar in just a few minutes. All right. Thank you again very much for attending. Hopefully that was useful. Hopefully you got to learn some tips that will make you more efficient. And if you need more information on tools that you saw there that you'd like to take a further look at, please do get in touch with us. Thank you again for attending, and have a great day.